Friends, welcome to video number 19 of Data Structures and Algorithm Practice with Akshaya and him. In this video, we are going to discuss problem number 19, problem number 19, right? Or actually problem number 1 of queues, right? Before we discuss this problem, let me emphasize upon the importance of this question. This question is so important for someone who is preparing for interviews at MNC like Amazon, Google, Microsoft, that you won't actually may be amazed, right? So let me just tell that to you. So the purpose of data structures and algorithm is just not memorizing things, it's just not learning the different kind of implementation, different data structures, or thinking of different problems and memorizing the solutions to them. The actual mastery of data structures, which is asked in interviews of these companies, is the ability to think and ability to go into your memories, ability to put those memories together, ability to put your thinking together and come with a solution. And not just any solution, but use thinking of a proper data structure which is suitable for solving the problem, right? And to be able to do that, you must understand how different data structures work, that is the basics, but you must also understand what are the advantages and what are the disadvantages of using a certain data structures. And not just that, that's just a start. What you actually need to do is be able to create new data structures on the fly to solve the problems which is given to you, and do that in the most optimized fashion, right? So this problem is a very good start for someone who's working on the starting or mastery of data structures and algorithms, and someone who is looking to learn for queues, right? Because this is question number 1 on queues and the question number 19 overall for the data structures and algorithm practice, the link for which you will be seeing down below. Let me introduce you about myself. My name is Akshay. I am from IIT Delhi, BTech Computer Science graduate, having worked at MNCs like Amazon and also at Paytm with as software engineer and senior software engineers. Further, I have trained a lot of students, some of which have also cracked these tech giants like Microsoft, Paytm, and are working a very handsome packages at these companies. This is really possible for anyone who has the right guidance, right, who follows the right things with right attitude and is really determined to put in the effort. If you understand the secrets which I can reveal to you, you will surely be able to crack these companies, maybe earn 12 to 30 lakhs INR per annum, even in India, even if you are fresher, even if you don't have any other experience, and maybe 100 to 200k US dollars if you are working outside India, right? So that's the importance of the mastery of these concepts with a proper guidance, right? So you can see a link below, click on that link and join in for practice. Okay, so now let's jump into this question straight and try to understand what this question is trying to teach us and what concepts we can learn. I will try to keep the video as short as possible. Okay, number of recent calls. Okay, number of recent calls sounds quite simple. Write a class recent counter to count recent requests. So the question has given you basically a template of an existing class, right? And it has given you certain purpose of the class, purpose of the functions involved, and you have to fill in the blanks. This is how this question is actually a half baked answer, right? Because it has already told you the solution to the problem, and all you have to do is do a fill in the blanks. Generally, in the real world, you wouldn't even be given a class in the beginning, and you will have to think of the class also, right? So this, because of that, the problem is bit simple. Let's dive deep further. It has only one method, ping, right, which is given an input integer named t, where t represents some time in milliseconds, right? So t represents a time in milliseconds. Always try to understand the problem by taking examples. One of the ways is taking examples on paper, and another way of doing so is taking example from real life. Try to draw an analogy of the computer science problem in the real life, and then you will be able to better understand this. So I am going to demonstrate that to you right now. Return the number of pings that have been made from 3000 milliseconds ago until now. Okay, any ping in the time t minus 3000 to t will count, including the current ping. It is guaranteed that every call to ping uses a strictly larger value of t than before. Great. So let me just give you an analogy about this, right? So one of the students also asked me this question, that he is not able to understand this question. So I gave them the example. I told them, think of the WhatsApp group, right? And in that WhatsApp group, can you find me how many messages have come in the past 24 hours, right? So how do you actually solve that problem? So initially the person was not able to identify, but when I asked them further questions, they got a good grasp of it and got a complete understanding and the confidence to do it immediately. So let me explain to you furthermore how the analogy works, right? So when I asked how do you count the number of messages that came in the WhatsApp group in maybe probably the past 24 hours, the student said that we actually just go and count, right? That's also correct. But here comes the importance of attention to detail and breaking down big things into small things. I always keep emphasizing upon this, that always view things with the help of a magnifying glass. So even if I have given you one statement or one formula or one secret of how to solve a problem, magnify it and see what I actually mean, right? You may be even able to go deeper and better than the understanding I myself have, if you are able to focus on it, if you are able to discuss with me and give your own time and understanding that. So coming back over here, when the student said that they can just go to WhatsApp and count the messages, that is correct, but you have to split down that into even further steps, right? So it's not exactly that you count the messages. This is how you actually go. You go to the group, you check the time of the last message, right? And you see whether this was within 24 hours or not. If it is within 24 hours, you add a count of one, that one message came, right? Then you go to the previous message and again you see whether this message came in the previous 24 hours, right? Again to the previous message, and so on and so forth, till you reach a message which came at a time before 24 hours, right? Or you reach a time, a message thread where it ends, right? Probably the first message also came within 24 hours, so all the messages came within 24 hours. So in that case the count will be all the messages that came. But let's say there are some messages which came even before 24 hours. The answer that you will obtain will be based upon starting to count from one, from the last message, and going one by one message up and keeping a count till the message that you are saying have been within 24 hours. And that's exactly what this problem is all about. Probably this also made you think and understand the problem even deeper and gave you even better insights to be able to solve this problem, right? Probably you paused the video or you were part of the group and were able to solve this question even earlier without looking at the solution which I am providing to you. But now when I have given you this insight, you will be able to understand or see the problem so clearly that you will be able to think of greater insights, right? As I always say, always try to do the same problem through multiple ways, through multiple solutions, by applying different techniques, right? And that is possible only when your mind is completely free, and your mind will be completely free only when the problem is crystal clear, right? For example, let's say you have a sketch, you have a sketch painting, right? Or basically a coloring book, right? And the coloring book has some designs inside them which are not colored. When that is the case, you can clearly identify the different parts and you can choose which part to color, right? You can also choose which color to give to different part. But let's say the coloring book has a picture which has lot of parts in it, lot of small things in it, then it becomes confusing, right? Another thing would be if someone else would have already given certain colors or would have made the margins of the drawing or the borders of the drawing difficult to see, your mind will get confused and you wouldn't want to do it. But as soon as you see a clear canvas or a canvas with less number of patterns in it, your mind begins to go creative and think of solutions, right? So that's why always and always try and understand the problem as simple as possible, and also the concepts that I have given to you already. Probably if you are already in the course, the concept which I have given, try to go deep into that, because that's the same formula that has helped my other students also to crack those interviews in probably just 1 month, in comparison to the previous time when they have been trying for 6 months, 1 year, or the 4 years of the BTech, but they were not able to, right? That's why clarity is important, and for clarity you need to focus and go deep. Okay, so now when we have understood the problem, let's get more specific about the computer science concept and specific about the data structures, like what this question is actually teaching us. So let's go to the code. So this is the code, and you're given a class recent counter, and it has been given two functions. One of the this is one of the functions, public int ping t, which you have to implement, and this is basically a constructor, right? So before we implement this, before you implement any kind of data structure, you should first think upon what functions you are being expected to implement, and after that you think of the data structure, right? But because we already have a data structure being given here, or kind of a class being given here, let's write down what functionality we are expected to do. Because until and unless you have the plan cleared up in your mind, you might take maybe 3-4 hours, a couple of hours, or maybe 1 hour to do this question. But time is going to be very important, because in online coding rounds you will probably be given 4 questions, 4 tough questions to be done in 2 hours, or the interviewer might give you a simple problem like this and maybe expect you to give the answer in maybe 2 minutes or 5 minutes, right? So you want to be fast, and for that, to actually be fast, you have to go slow, which actually means that you have to write the clear thoughts of your mind into a form of pseudocode. And once you have done, converting that pseudocode into an actual code is pretty simple, right? So let's try and write what is the ping function expected to do. The ping function is actually expected to do only one thing. It's supposed to return number of pings that had come previously, which fall within a time range of 3000 milliseconds from the time t. Time t is the actual ping, so we have to may have to go back in the past up till t minus 3000 and see how many pings came to that, and we have to return that, right? Okay, so this is the actual function, but to be able to do that, we need certain kind of information, right? What is that information? We basically need all the pings, right? We need the pings that came before, right? We need the pings that came before, but presently we don't have any kind of data structure or any kind of information storing structure present in the code that can store the pings, right? So let's say if you had that WhatsApp group, right, but you didn't have the previous messages saved with you, you won't be able to find the count, right? So that's why you need all those messages up. But right now, if I just tell you that X, this message came at 5 p.m., how many messages came before this, you won't be able to give the answer. You actually need to be able to save the previous messages along with their timeline, right? Along with their timestamp, right? And the only function which is being called is ping, right? That's why this ping function must also, so this is one thing that it is supposed to do. The second thing is must store the ping that has come just now, right? The ping method cannot store the previous messages, but it can only store the message that came right now. So that's the only thing that you have to do, right? So to ensure that you be able to do this function, you need all the pings that came before, right? And for that, the same ping function will have to store this, right? And if you do this, your problem will be solved, right? Because you have all the previous messages, and you have to just go back and count how many of these messages were in the right range of 300 milliseconds, right? Okay, so probably someone who is just starting or doesn't have the experience of cracking interviews or not doing a lot of problems would think, okay, now the job is done, now I can intuitively solve the problem, okay? But that's a biggest catch, okay? This problem is pretty simple, so probably you will be able to solve it intuitively, okay? Or maybe You may be able to solve it by doing it wrong the first time, but after doing 3-4 wrong attempts, maybe in a couple of hours, you will be able to do it right? But that's a problem. You must be able to have a clear thought, the clear proof method mathematically before actually trying it out, right? That's why I always say, always work on your problem solving skills and make sure you are 1000% at that, and also at your mathematical ability to prove things and be 1000% at it, right? Only then you will be able to do those calculations in your head and be able to come up with a beautiful solution for this problem in probably just 2 minutes. Okay, because otherwise you will keep going into different directions, but we want to be focused, right? That's why that logic proof should be going inside your head very fast, right? And for that you must practice that on the problems that we are doing, right? And if you don't know what I'm talking about, probably you can join the course and learn more on that. Okay, so must store that ping that has come just now, must store the ping that has come just now. So how can we store this thing, right? They can be different kind of data structures. If you have been following till now, you would have seen using different kind of data structures, right? We use tags, linked list, arrays, hash tables, hash map, hash set, and lot of things, right? So which one are you going to use? Don't just follow your intuition, but apply logic, right? So one of the ways could be of using a hash set, right? You can just whatever number, whatever time comes in, just put into a hash set, and then when a new ping comes in, you just find the corresponding number. Let's say the current ping came at maybe 5000, so you go into the hash set and see 5000 minus 3000, which is 2000, that did the ping came at 2000, and you will get that in order 1. Then you check it for 2001, that comes in order 1, and you will be done, right? Sounds pretty good, right? But there is a problem in this. The problem is all the pings that are coming are not really contiguous, right? You cannot be sure, you cannot find the next number. Like if you are at 5000 right now and you do 5000 minus 3000, which is 2000, you get a single number, and you check in from the hash set whether 2000 is there or not. You either get a yes or no. After that you will check for 2001, again you get a yes or no. And imagine if there was only one ping and that ping was 4999, you will be able to come to that previous ping only when you go from 2000 up till 3000, then 3000 to 4000, 4000 to 4999, that you will be able to get. And because of that, the time complexity will be huge, right? So even when the hash set has an order 1 complexity for finding a number which is already there, right, it is not a useful technique when you need to search for different values, right? In that case, probably a array might be useful, right? Because in the array, because probably, let's say first let's use list, right? Probably a list will be useful. Why? Because in list you don't have to jump onto values and check whether they are present. You have a contiguous set of information, right? So let's consider the example which you just considered right now, that the present ping is 5000, right? So we we don't need to actually check for all the pings starting from 2000, 2001, 2002, and so on. We'll just go to the starting of that list, right? And probably the list start is 1000. Then you check the next value, maybe it is 1005. You keep on checking the next value in a contiguous fashion till you come probably equal to 2000, right? And you can be sure that starting from 2000 till the next number and so on up till 5000, you have found the pings which fall in the correct range, right? So a list seems to a better option than a hash set, right? Now let's think about an array. Okay, so an array can also be pretty good in this, but the only problem with the array is that array size is limited, right? Array size is actually limited, right? So let's say the array that you have defined had 50 elements, and now 51st elements comes in. You will have to create a new array, and when you are creating a new array, you will have to copy all the elements and paste that into new array, right? But the array doesn't offer you any kind of advantage over the linked list, but except for one, right? And that is the ability to find the numbers using a binary search method, which is not present in the list, right? So let's say you went to the start of the ping and the start of the ping was 100 and the final ping was 5000. Now with the help of a binary sort in the array, you would be able to find probably 2001 much more faster, maybe in log n time, where n is the number of pings that have come till now, n is the length of the array. So in order log n time you will be able to find, right? So in this way you can use different kind of data structures and find whichever suits best, right? I didn't go into much details and I didn't show you how I thought of, how I proved the things in my mind, right? It may seem very intuitive to you right now, but I'm myself thinking a lot on that, and that is helping me guide in deciding which problem, which data structure to use right now, and which data structure should I choose from the point of view of bringing something new to you. Okay, so first thing was understanding what all the question is asking you to do, and the second thing was also about choosing the kind of data structure, right? And once you do that, you will be able to do. Now let me just improve upon the algorithm also, right? So we are pretty sure that we are not going to use a hash set, but we are going to use a list of pings, right? Now if you need to find out how many pings fall in the range of present t up till t minus 3000, right? Present t to t minus 3000, one way of doing that is starting from the beginning of the list and coming with the help of and finding with the help of a binary sort in an array, or by with the help of link hopping in a normal list, which is that element, and return size minus the number of nodes traveled till now as the output, right? That is one method, and the time complexity of that would probably be can be order n, because the entire array or the entire linked list need to be traveled, and if you are using an array it may take log n. Similarly, another method would be a more efficient method, which may seem over here, is that instead of traveling from beginning, you start traveling from the end, right? If 5000 came right now, see what was a ping just before that, then see what was a ping just before that, because all of these are actually going to be get counting. When we are starting from left side, those are not really getting counted, right? But when you're starting from right, all the pings are going to get counted till you come to a ping which is too old, right? Which is probably older than 3000 milliseconds from the current time, right? So it seems better to start from the right hand side. Okay, so in this way you can think of different ways of going through this, and in all these cases the time would probably be like something like log n, or you can improve upon that, right? And when there will be a lot of pings, let's say 1000 pings have come till now, right? The ping method would be also counted 1000 times, right? So if in each operation it is taking log n time, right? If let's say n pings have come till now, in the nth ping it's going to take log n time. In the n minus 1th ping it took log of n minus 1, and so on up till 1, right? So it will basically become something like n log n, right? What if I tell you there is an even better way of doing this, right? Probably you can do this in ordered time, where n is the size, is the number of pings that have come till now, right? That will be really a superb idea, right? And for that, let me bring that algorithm to you. What we basically need to do is, whenever a new ping comes in, we just store that, in a linked list in probably the increasing order of times, right? And you go to the beginning of the list, and you see whether this ping, the original ping, the first ping, is within the range of 3000. If it is, very good. Okay, it's very good, we have got the answer, that the entire length of the list is the answer, right? But let's say it is not, right? This means that the head of the list is not going to be useful in the current ping, so we will move to the next. But at the same time, we also know this, if the head of the list is not useful for the current ping, it won't be useful for the ping that comes anything in the future, right? For example, let's say the current ping is 5000 and the head is at, let's say, 100. We know for sure 100 is not within the time range of 3000 milliseconds with the current ping of 5000, right? And the next ping is always going to be more than 5000, right? It may be 5001, 5002, maybe 6000, and for even for these pings, the ping of 100 millisecond won't be useful, right? So there's no use at all of storing this ping, so you basically remove that, right? So if you get a new ping, you go to the beginning of the list, right? You see whether it is useful for the current ping. If it is not, remove that, move to the next ping, see if whether it is useful. If it is not useful, remove that. But if you come across a ping which is useful, return the length of the current list and you will be done, right? Similarly, when the next ping comes in, you will follow the same strategy. And this algorithm will actually take a time of order n for the entire pings that have come till now. Why? Because see, you're always starting, whenever a new ping comes in, you insert it towards the end. So it's done in order 1. And then when you're checking the count of pings, you're starting from the beginning. You're starting from the beginning, and if it matches, if this one matches, you stop over there and you give the answer. But if it doesn't matches and you have to travel more, you will not come across this ping anytime in the future because it will get removed, right? So each ping in the list of stored pings is going to be considered only once, right? It will be considered only when it is useful in the preceding window of 3000 milliseconds, or it will be removed and it won't be considered in the next pings. And because of that, each time when a ping comes, if you are looking at a new ping, it will be either removed, right, or it will be considered. And because of that, the time complexity is going to be order n, and the space complexity in the worst case is also order n. Okay, so I have already the code ready with me, so that I don't make a mistake and take longer in the video to explain to you. So let me just copy paste this code and explain to you the same logic that we just did. Great. So as you can see, yeah, so I just missed to explain you one very special part. So when you understood this kind of a data structure, what comes into your mind? To my mind, what comes is actually a queue, right? You are actually looking at the beginning of the list and you're going to remove it, and once removed, you are never going to see it again. What happens, which data structure is that in which this happens? That is actually a queue, right? First in, first out. So whatever ping came first, you would consider that first, and if it is useful, you will keep it, otherwise you will remove it, right? Great. So you could actually implement this problem with the help of a queue, but what I'm going to do is I'm going to break this into a completely simple data structure so that you learn and understand the ability to create data structures on the fly. You don't even have to think in your mind whether it's a queue or not, but you simply take up the advantages of a data structure like queue and implement over here, right? So the only information that I needed was of creating a node which can store a value and which will have a next pointer, and I created a constructor for that. As simple as that, right? And why did I need that? Because I needed two nodes or two kinds of information. Basically the head of the list and the kind of the tail of the list, right? At one place I am going to insert the new node, and at one place I am going to check whether it is in the window of 3000 milliseconds, and if it is not, keep removing that. And I'm also maintaining a size variable because I am supposed to use this size variable, right? I'm going to return that as in order 1, that how many pings are present in the list, so that I can give the answer of ping in order 1 time, right? Great. So here the entire functionality of this ping function is all about how do we insert it, right? Okay, so great. So let's say a new ping comes in. What is a possibility? First possibility is that our list is already empty, right? Our list of pings is already empty, and for that, if you want to insert a new node, you would have to check whether it's empty or not, and that can be checked with the help of head is equal to null, right? So if head is equal to null, you will create a new head, right? You will assign the tail also equal to head because this is going to be the first node. You will assign size equal to 1, and then you will simply return 1. Why? Because this is the first ping. Now as I'm sharing you this, I am pretty sure that my code is correct because in my mind I have mathematically proved it, right? You should be able to do that also, because if you do that, then only you are actually preparing for interviews, because you're preparing for certainty. If you're just looking for fluke, then most likely you won't make it. Why? Because see, each great company is going to have a series of interviews, right? They won't just have one interview, they are going to have a series of interviews, and these interviews are going to give their input eventually, that what are probably the signs that they saw in you. So if some of them, if each one of them observe in you that you probably are not able to prove things or try hit and trial method, then it might raise a red flag, right? Secondly, if you are trying the hit and trial method, you might actually pass through the first interview, but because of probability, your second interview you are going to fail, right? And there are going to be multiple series of interviews, right? So that's why it is very, very important to be able to develop that logical thinking, that problem solving ability, the mathematical proofs ability, to be able to solve these problems. Okay, so great. And for that, you can probably join the courses also. You can message me and I will share details on that. But for now, let's focus on this question, right? Another condition which I had put over here was t minus head dot value is 3000, which basically says our head also doesn't fall in the range of 3000 milliseconds, right? So basically remove this also, right? This is like saying the last ping that came was at 4 millisecond and our next ping is 5000. So because the head and the new ping has a difference of more than 3000, the entire list can be discarded, right? So that's why I'm creating a new list, right, like this. Great. The second possibility is you already have a list, right, where where neither the head is null nor the current head has a big difference, has a difference of time greater than 300,000 milliseconds. In that case, you are going to insert it at the beginning. Okay. But before that, there's another interesting thing, which is basically checking if t minus tail dot value is less than equal to 3000, right? Which is basically like checking whether our beginning of the list, or rather you can call the tail also, but if you are dealing with the queue, this would actually be the head, right? But right now, according to our terminology that we are using, because I just created a random new data structure, we are going to call this tail, and we are going to see, does the current ping minus a tail values ping is less than equal to 3000. If it is less than equal to 3000, this basically means the entire list is going to be counted within the range of 3000 millisecond, and we don't need to delete anything. We just need to append the new ping at the beginning, at the head of the list of all pings. So that's what I'm doing over here. I just created a new node, right? And I assigned that next temp.next equal to head, and then I assigned the head equal to temp, and then I ensured size plus plus, and I returned size. Okay. Again, as I wrote this code, I in my mind mathematically proved that this code is actually working. Okay, so it's very, very, very complicated or very beautiful to say in a way, but you should be able to do that. Find why your code is working, be able to mathematically justify, because this is not only going to help you solve problems, but will make you a better communicator to your interviewer and also to your colleagues, right? So all the great companies basically have a lot of code reviews. Whenever you write a code, your peers are going to review that code, and basically how they are going to review, they will check for normal bugs, and they will also try to see the logic part of it. And sometimes you may not be able to communicate to them your code is correct even when it is. Because of that, they might be actually resulting into multiple reviews, and a lot of time will be wasted, right? That's why these people or these companies will look forward to people who can better communicate, and that's why that is emphasized even in the interviews. There are also a lot of deeper reasons, but I am not getting into that so that the video doesn't go very long. Great. So till now we know that the list was not empty, right? And second, the entire list need not be considered, right? When we reach over here, we come to know that the current time is actually somewhere between the last ping and the beginning of the ping. So we will have to find the corresponding one in the middle, right? So that's what I'm going to do over here. I just declared a iter equal to head, and I'm going to find out uh, at which position that is, right? And I declared size equal to 1 because I will begin counting from this and go backward till the time I reach a ping which is falling, till the time we are coming across pings which are falling in the window of 3000 milliseconds, and I will keep incrementing size plus. So while t minus iter dot next dot value is less than equal to 3000, size plus iter equal to iter dot next, right? So basically we started from the current node, went size number of nodes behind till the time the next node value, till that time either till the time the next ping's time is greater than, has a time window of a difference greater than 3000 millisecond, right? And when that is done, I break the loop and then I assign that value equal to null, right? For example, let's say we were at 5000 as a new ping, then the previous ping was 4999, before this was probably 4000, right? The previous one after this was let's say 2007, right? 2007 is also within the range of 3000, but after this the next one is probably, let's say, 1950. Now 1950 is not within the range of 3000 with 5000, so as a result the entire list of nodes which is starting from 1950 towards the end will be removed with the help of iter.next equal to null, right? And then I will also have to update tail is equal to iter. I will have to update node temp is equal to new node. Then I will say temp.next is equal to head is equal to temp, size plus return size. Okay, so again, even here also as I am doing this, it came into my mind, I was proving this, that why this code will work, and I put all the logical things together and I'm mathematically sure that this code is working. That is, my entire class, the entire class is going to work as a functional unit. Nothing is going to break, right? Let me just emphasize this with the help of the example of databases. So in databases we have something called as atomic operations, right? What is the definition of an atomic operation? Basically there are certain properties of the database which have to be true all the time, right? But when you are executing a certain operation, that rules might be broken during that operation, but once that operation is complete, all the rules which existed before the starting of the operations must exist even right now, right? For example, let's say when you are taking money out of the ATM, right? So when you are doing so, if let's say two people are withdrawing money from the ATM, let's say you are withdrawing money from the ATM and probably your husband is withdrawing money through net banking, and you had probably $5,000 in your bank account and you withdrew $100, right? When you withdrew $100, the command which will be sent to the bank is change the value from 5,000 to $4,900, right? And at the same time, probably your wife or husband, let's say, put in more money, right? Let's say they put in the amount of money of $500. So the command that goes to the bank is store, instead of 5,000, save the value as 5,500, right? Now if these two operations happen simultaneously, only one of them is going to happen, right? And probably let's say only store as 4,900 got written, or maybe the 5,500 got stored first, then your next operation of store the value as 4,900 came and the value got stored as 4,900. Because of this, lot of information is getting lost, right? And for that we have defined something like atomic operation, which basically ensures that if someone has accessed the value of information and is updating that information, which is the amount of money stored in the bank as is 5,000 and now change it to 4,900, no one else can execute any operations. And because of this, first your operation of withdrawing that $100 will be executed, because of which the new value which will be stored in the bank will be 4,900, and when your husband puts in $500, that operation will be executed, and now the new value which will be stored is 4,900 plus 500, which is $5,400, right? Similarly, even in a class or a data structure or a loop, recursion, whatever it is, you have to ensure that such kind of rules are maintained, right? And that's what I did when I was writing this code. When I was reading this code, I ensured that those rules are being met, and that's why I'm pretty sure the code works. Okay, So that's how we do it. Let me just submit this code and show it to you that it works. Great, it works. It's having a good runtime, right? And the memory usage is also pretty low. So it's a very good code because the space complexity is order n, right? Because that's the number of pings that are coming in, and the time complexity is also order n, right? I hope you enjoyed the video. You got to note down a lot of tips and tricks that I gave. Okay, I hope you have clicked the link and joined the group for data structures and algorithm practice, which can help you move from maybe a package pretty low, maybe 4 to 5 lakhs or 9 lakhs or maybe no job at all, right? Being an engineer without any experience, to move to a job with a minimum salary of 12 lakhs or even up to 30 lakh per annum salary if you are in India, or 100 to 200k USD dollar salary if you're working outside. I hope you learned a lot and are at least motivated to start practicing. So click on the link and join in. If you're interested, you can probably message me for joining on the courses also, right? Whatever you enjoyed about the video, please post down below so that I can understand what is that part which you love to hear upon, so that I can focus or emphasize upon that more. Because I myself, having been done these questions, I have my own blind spots and I have my own assumptions, because of which I may assume certain things to be obvious to you as a beginner or someone who's coming from a different background, but may not be obvious, right? So emphasize on that part that you learned in this video. Also emphasize upon the part of understanding of explanation that you learned, so that I can ensure that I maintain that in the upcoming videos as well. So right now I again ask you to like this video, right? Drop the comments below what you loved, share it with your friends, because it is going to be encouraging to me. Also it will give me inspiration and I will create further more videos like this. And don't forget to subscribe. Okay, so bye bye, take care, we'll catch you in the next one.